All right, good afternoon, everybody. We're here this afternoon with Dr. Gabe Silva from UC San Diego. We're very excited to be with Gabe. Gabe is really one of the top neuroscientists in the nation. And what we're really always trying to do at the Entertainment Technology Center is really push the limits on what kind of cutting-edge technology and science and knowledge we can apply to industry problems like audience intelligence, right? So the media and entertainment industry is extremely interesting in that it creates extremely complex, extremely cognitive products that really aren't fully known, right? The history of media is people have been creating media, and that media has been successful. The mechanisms behind the creative process, the neural mechanisms behind the creative process and behind the consumption of media process have been sort of pretty opaque. And so, this slide sort of puts it fairly well. It's that, we are, our brains perceive narrative, media narrative in a way that's still very, very opaque, and a lot of the content creators not only have very little input into what kind of cognitive impact their content has on their audiences, but even the audiences themselves don't fully understand what happens when they watch a movie or they watch a TV show and sort of the process of affinity. So we're very excited to have you here to talk about the neuroscience of narrative. Some of the things that we've looked at, right? So there's actually very, very little research around the neuroscience of narrative, especially in media and in film. The only study that we could find that was somewhat substantial was Yves Bergquist's neurocinematics study in 2000, it was 10 years ago, looked at putting people in Fmri machines and did some eye tracking and made them watch specific different kinds of content and measured their brain activity and tracked their gaze. And in looking at different kinds of content, and the study was very surface level. It was really about how much attention is being paid to what kind of content. So they compared the brain activity for people looking at a Hitchcock movie versus a Sergio Leone movie versus an episode of Curb Your Enthusiasm, and a completely straight blank shot of Washington Square Park, fixed shot of people just walking in and out of the frame. And if you look at the slide, it's really interesting because the closest to the segment of reality was Curb Your Enthusiasm, which is really interesting because it's notoriously a show about nothing, right? And so cognitively, the cognitive signature was the closest to nothing. So, we have done at ETC a little bit of work on looking at what we call brain-to-brain mapping, which is we look at, what kind of emotional tonalities and narrative structures are being expressed in media content, and then we look at social media data, looking at how do those attributes resonate or not in audience conversations, cognitively using audience conversations as a proxy, and it's a pretty bad proxy, right? So, but this is an example of what we've done. We've processed about 650 feature film scripts and looking at what are the dominant emotional tonalities of the characters in those scripts. And if you look at this, it's really interesting because a lot of it is extremely negative, right? It's stress, neuroticism, melancholy, insecure, artistic, aggressive, et cetera, et cetera. So those are the most recurrent traits of characters in film in the past 20 years in feature film. Those are the least common character traits in characters in film, and you see a lot of positive things like dutiful, humble, happy, conscientious, organized, genuine. So this is the kind of stuff that we're doing. It's still very raw, and we're to try to do this brain-to-brain mapping, we're looking at what kind of emotional tonalities have the biggest ROI in terms of box office returns. Right? So we've looked at all the films, we've mapped all the characters in the films, and then we've looked at the box office returns of the film, and we sort of plotted that. And we looked at what are the characters that have the highest resonance as far as box office return goes, with audiences, we saw that dominant traits like impulsive, sexual focus, liberal, anxious, cautious, open, active, and persuasive had fairly high ROI, but weren't necessarily very present and very recurrent in cinema. And the characters that had very low ROI, on the other hand, had character traits that were very, very highly present. So, this tells us that there maybe is a disconnect between the characters that are being created in media and the characters that audiences want to see, the characters that really resonate with them cognitively. So to really address this, run us through neuroscience today, right? And what we're able to do today that we weren't able to do 5 years ago. And where's the field today, and how well do we understand the brain today?
Yeah, that's a big question. So as a field, it partly depends on, it's a collection of subfields, of course. Our ability to interrogate or measure the brain is that the technology has just progressed tremendously over the last even just 5 years, certainly 10 years. It depends a little bit at the scale at which you want to do a measurement. Mm-hmm. So you showed an example of functional magnetic resonance imaging, or Fmri. And so that's a primary tool by which neuroscientists today interrogate cognitive sort of responses at a neural scale, a neurophysiological scale. And that's because you can actually put a human in it, it's non-destructive, you can actually make a measurement. And the idea with Fmri is, so magnetic resonance imaging images structure in the brain. It's essentially an optical sectioning as you go through the brain, and you can look at structure. The idea behind Fmri is that what you're imaging is various forms of blood flow. And so the concept behind it is that as different parts of the brain, different groups of neurons are working harder, they're computing harder, if you will, there's increased blood flow to those regions because it correlates with neural activity. They need more energy, more glucose. There's waste products, if you will, that have to be shuttled away from that area of high activity. And so there's a presumed correlation between neural activity and what the brain is doing with those areas of elevated blood flow. And so that's the basis of Fmri. And then, of course, there's many other methods that at different scales at which one can study the brain, from molecular and genetic up through cellular networks. And so there's a hierarchy of sort of methods that accommodate different spatial scales. Mm-hmm. That's the methodology part. In terms of where we are, we know a lot of the details for what we're struggling with, and sort of at the forefront of the field is, how do we understand the brain as a system, right? What are we understand a lot of the pieces, and we do have a lot of information on a lot of the pieces, but trying to put that together into a coherent picture of the brain as a system, as a computational system, and all the nuances is quite complex. And we understand parts of it, but certainly that's at the forefront of where a lot of the field is. And then there's a gap between the neuroscience and sort of the cognitive science and psychology experiments, and that gap used to be very wide, a generation ago, where neuroscientists really wouldn't talk to psychologists or cognitive scientists. There's too much of a divide, and now that's becoming narrower and narrower. So that's sort of an overview of where things are right now.
Do you feel that we have a reasonable grasp on the structure of abstract thought in the brain? So we have a pretty good grasp on the sensory motor data, right? How do you feel the science, where's the science in inferring the structure of thought?
Well, again, that's it depends on what you mean by thought, right, and abstractness, right? So the thing about the brain is that it's a complex system, right? And so it's not complicated, it's complex. And the way I distinguish between those two is, take something really complicated piece of engineering like the space shuttle, right? So there's an engineer somewhere that knows the function and purpose of every bolt and every nut in that space shuttle, and how that bolt and nut and every single piece contributes to the whole, which is the entire space shuttle and what it does, right? In a complex system, there's an emergent property that comes out, so that the individual pieces, just understanding the individual pieces is not sufficient to understand the whole that emerges from that, right? And so that's a complex system. And when it comes to sort of higher cognitive processes in the brain, and there's some, the big ones, right? So we think about consciousness and self-awareness, and there's individuals or neuroscientists, for example, working on trying to understand how humans perceive and do math, for example, right? Which is extremely abstract. There's an entire debate as to whether machines will ever be able to, philosophical debates, whether machines will be able to match that, that go all the way back to Gödel's theorems in mathematical logic, right? And so those highly sort of abstract and cognitive processes, we just don't have a good grasp on that. We have little pieces here and there, but these are very, very active areas of research, obviously.
In terms of neuroimaging, in terms of because where this is leading to for us, right, is the ability to understand narrative at a fairly granular level on an individual basis, and to understand content from the perspective of what kind of cognitive impact does that content have, and the parts and pieces of what is the meaning of the color green, what is the cognitive impact of the color green in this context, what is the cognitive impact of specific characters, et cetera, et cetera. What is the state of the neuroimaging? What is the state of the tools that we have beyond fMRI that may be a little bit more precise or less precise and more portable, or maybe more precise, less portable? How does the hardware of neuroscience, how is that evolving?
Well, the number of the tools are there, and you had an example of where they have actually done some of these studies. I think the challenge from the perspective of breaking down narrative and content and trying to understand that is that it is a very personal experience, right? And so the perceptual world that each of our brains creates, sort of the internal model that our brain creates of the physical world around us, I mean, that's a very personal experience. And so you gave the example of the color green, right? And I can explain to you what green looks like and feels like to me, and you can explain it what it feels like and looks like to you, but I will never really know what green looks like to you, right? And again, some of these abstract concepts, the challenge is that they're self-referential, right? So, again, take something like consciousness, right? The reason we have such a hard time trying to even define it, let alone study it and understand it, in part comes from the fact that it's a self-referential concept. So I assume that I'm conscious, right? And I think you're conscious, right? But so how do I test that? Well, I test it through a series of interactions, right? But sort of the extreme example of the Matrix. I mean, if we're living in a completely digitized universe, and then we wouldn't know it. I mean, there's some truth to that too, right? So the challenge with trying to break down narrative as a systematic process is tying together the measurements that are being made, whether it's fMRI or other methods, right? And this applies to sort of storytelling in general, right? Trying to tie together the measurements you can make and the responses that they have with the internal effect that it's having in the individual those measurements are being carried out, right?
I see.
And so it really becomes a statistical problem,
Yeah.
right? It's a statistical effect, right? When we say, when someone has an EEG done and we say, well, that's a normal pattern associated with sleep, for example.
Mm-hmm.
What does that really mean? Well, what it really means is that we've done enough EEGs on enough people over, decades and decades, where we know that, a neurologist detects that pattern, and statistically speaking, that's the pattern that's been observed, correlated with an individual sleeping, for example. But it's a statistical phenomenon.
Yeah.
And a similar challenge will exist in trying to break down, that narrative equation.
But however, lots of people are very inspired by Blade Runner. Lots of people are very, have been terrified at watching, Get Out, or lots of people have enjoyed The Matrix. So there has to be a common experience behind all of this.
Oh, absolutely. And what I think is most fascinating is that in a number of ways there's a common experience across things that make us different. So culture and languages, right? And we tend to laugh and smile at similar things, right? So there absolutely is sort of an underlying common structure to that, and teasing that apart, I think, is a big part of trying to understand sort of that common, how do people react to a story, right?
In terms of narrative, so narrative is a very powerful thing. It's also a very mysterious thing. So narrative really, if you think about narrative at a very philosophical level, it sort of drives every single one of our decisions. And you can think about narrative in a very procedural way, where it's sort of, we're building procedures in a way that is structured around the narrative. And so it's very, very powerful and it's very mysterious. How do neuroscientists think about the cognitive function of narrative?
Most neuroscientists don't, and it's really kind of an emerging field. It's an opportunity, right? There have been some studies I'm aware of where they have, and you actually showed, a couple of them, where they have broken down the sort of narrative elements, and that's a logical place to start. You have some content, and you break it down and you look at the responses, in terms of what the brain is doing, as that content is presented. There's comparatively much less work sort of looking at this idea of, how does narrative and storytelling come together, and what's the commonality across different media, for example, right? There's and part of the reason that there just isn't much out there is that the tools to be able to interrogate these processes, because this is quite a complex process, right? I mean, the tools to be able to interrogate that are really only now sort of coming online. And so the opportunity to study that in a formal way, beyond sort of the classical cognitive and psychological approaches, but from a neurophysiological perspective, those tools are really only in the last several years really sort of coming to the forefront, and so I think it's a tremendous opportunity.
Do you find yourself, when you're watching a TV show or a movie, you as a neuroscientist find yourself thinking about how your brain is possibly reacting to specific aspects of the film or characters?
Yeah, absolutely. Yes, I do. I mean, it's interesting to think about how the brain predicts what's going to come next, how we viscerally react to what we're seeing, how history, right, plays into that reaction. So an individual's life experiences, right, will absolutely have an effect on that. So yeah, there's all kinds of open questions to explore there.
Okay, well, this is for another day. Thank you very much.
Thank you.